Pluto remains one of the most famous astronomical discoveries in history. While we often view it as a triumph of exploration, its discovery was actually the product of a massive mathematical mistake. The problem began in 1781. Astronomers had just discovered Uranus, the seventh planet from the Sun. But as they tracked its orbit over the years, they noticed it was wobbling. Its path through space drifted slightly off course, defying Isaac Newton's laws of gravity. Instead of questioning Newton, mathematicians hypothesized that a hidden planet was pulling on Uranus. They calculated the exact mass and location required to cause that specific wobble and pointed their telescopes into the dark. They found Neptune exactly where the math predicted. Because that prediction was so precise, astronomers began to believe that planetary mathematics were infallible. However, Neptune's gravity couldn't account for all of Uranus's orbital quirks. The equations suggested an even larger gravitational giant, Planet X, was lurking further out in the dark. Percival Lowell, a wealthy American astronomer, poured his fortune into hunting this phantom planet. He built a dedicated observatory in Arizona and spent years scanning the sky, though he died in 1916 before he could find his giant. 13 years later, the search was handed to a 23-year-old named Clyde Tombaugh. The work was grueling. He photographed the same patch of sky on different nights, comparing the plates for hours to see if a single speck of light had moved against the background of stars. On February 18, 1930, Tombaugh spotted a tiny, faint dot that had shifted its position across two photographs. The world celebrated the discovery of the massive gravitational behemoth they had been hunting for decades. They had no idea they were looking at a mathematical illusion. Back in 1930, telescopes were relatively weak. Because the original equations required a heavy mass to disturb the orbit of a gas giant, the scientific community assumed Pluto was roughly the size of Earth. Over the following decades, as technology improved, the visual data began to clash with the theory. By 1949, new calculations suggested this supposed giant was barely the size of Mars. The true scale of the error remained hidden until 1978, when astronomers discovered Pluto's moon, Charon. This diagram illustrates a core rule of astrophysics. By measuring a moon's orbital speed and its distance from its host planet, scientists can calculate that planet's exact mass. Charon's discovery provided the specific variables needed to weigh Pluto directly. When they ran the numbers, the 50-year-old illusion shattered. The planet at the center of their calculations shrank to a near-invisible dot. Pluto's total mass is barely 0.2% that of Earth. A rock that small lacks the gravity to pull gas giants like Uranus or Neptune off their orbits. The entire search had been based on an error. The original 19th century measurements of Neptune's mass were slightly off. When those flawed numbers were used in the equations, they created a phantom wobble that never existed. Astronomers were looking for a monster, but they stumbled onto a tiny, wandering rock that just happened to be passing through the exact patch of sky where their broken math pointed. The accident eventually forced us to look deeper. By studying Pluto's neighborhood, astronomers identified the Kuiper Belt, a vast, frozen landscape of ice and rock. And in 2005, they found Eris, an object even heavier than Pluto. With more icy bodies appearing, the International Astronomical Union had to rewrite the rules. In 2006, they added a new requirement. A true planet must have the gravitational strength to sweep its orbital path clear of debris. Massive planets pull in or eject the space rocks around them, but with its 0.2% mass, Pluto shares its lane with millions of other comets and asteroids. Because it couldn't meet this final requirement, Pluto was reclassified as a dwarf planet. Correcting a 19th century math error ultimately forced humanity to redefine our solar system. Despite its demotion, our curiosity about the accident remained. In 2015, the New Horizons probe finally arrived to see Pluto up close. The probe revealed Sputnik Planitia, a massive heart-shaped glacier of perfectly smooth nitrogen ice. The atmosphere is also active. When solar radiation hits methane in the air, it creates heavy organic molecules called tholins, which drift down to the surface as a deep, rusty red snow. Beneath this freezing exterior, the dwarf planet's internal heat likely maintains vast oceans of liquid water. the math that predicted it was wrong. Its planetary status was revoked. Yet this error led humanity straight to the complex, beautiful King of the Kuiper Belt.